Hello, everyone. This is October 26th. This is I almost said the Ingress Internet meetup. This is the Cube Philly meetup, this CNCF meetup, which, like I was talking about before, this is guided by the CNCF Code of Conduct. If you have any issues with someone, please report them to me or anyone at the CNCF SIG chairs. We've got an action-packed one today. We're going to be learning about policy management, which I'm excited about because I just realized too, from an Ingress perspective, we only talk about pod security, and it's actually coming up from a deprecation perspective. So I hope I'm not stealing too much of your thunder, Jim. So it's something that I know we need to, as a community, start attacking. Just wanted to go ahead and kickstart and say that we've got action-packed lineup as well. We've got November, December lined up. So also, if you're looking to speak, please let me know. We can get you posted into January and out from that respect. So we generally give a little bit of an update, but as I was telling folks before we got started, I haven't had a chance to put together an updates from KubeCon or things like that. I know they're going to be released, I think tomorrow. I think it was the 27th or end of the week. Does anybody else have the answer
29th.
On that one? Clarify. 29th. Thank you.
Friday the 29th.
Yeah. So all of the videos from KubeCon are going to be released on the 29th with that. As always, I like to give a shout out to the blog from a CNCF perspective. The two, as I keep saying, it is near and dear to my heart because I help maintain it, but this actually is coming out, choosing your ingress controller. So identifying some of the requirements. And as always, big networking nerds. So understanding what the role of Envoy is. So these are two really good blog posts that you should probably go out and read. And with that, I'm going to open up the floor to anybody who is possibly looking for a job, or hiring, or has any community updates that they would like to talk about, or any projects that they would like to let the community know about.
I'll start.
Okay.
Hey, everybody. I'm Julia. I am based actually in Montreal, and I am one of the organizers of the CNCF meetups in Eastern Canada. So that covers, well, we're trying to cover pretty much the world now with the virtual meetups, but basically Montreal, Toronto, Ottawa, Quebec City, Halifax, Kitchener, Waterloo, like that whole area. So we just had our meetup today, and all of Canada pretty soon. So I just wanted to come in and let you all know about a new thing that we're doing in Slack, in the CNCF Slack. So Thomas and I, who's also here, he had this great idea to start an initiative around burnout. So for those folks who don't know, I did a talk about my burnout and mental health journey at KubeCon this year, and I got a lot of great response, and I think that topic is important and timely, so we wanted to keep the conversation going. So in the CNCF workspace Slack, there is a channel called Burnout. So if anyone is interested in contributing, listening, it's a support group basically. So we're going to be starting that on Thursday at noon Eastern, and we're going to do them weekly for now, and there are going to be little audio huddles. And so that's what we're going to do. I'm going to paste the link here to the Slack channel, and I'll also paste, if anyone attended KubeCon, I'll paste a link to my talk, but it will also be available on Friday. So if anybody wants to listen to that or contribute, or anyone's struggling or knows someone who's struggling, please join us. So thank you for having me here and for letting me share and talk about this and promote it.
In one of the maintainer circles conversations that we talked about, burnout, even from the maintainer's perspective, is really high right now. So it is a topic that we need to address as a community. So thank you, Thomas and Julia, for both doing that.
Yay.
Awesome. Anyone else have any projects, things that they want to talk about to the community, questions raised? All right, with that, then I will go ahead and hand over the reins to Jim so he can go ahead and get started. Jim, you are now co-host, and it's your show now, sir.
All right, well, thank you. Thanks, James. Thanks, everyone, for having me. like James introduced, the topic today is Kubernetes policy management, and I'm going to showcase that with Kyverno, which is a CNCF sandbox project. I'll talk about why we created Kyverno, what it does, how you can use it, some of the use cases that it can help you address in managing clusters, automating security best practices, and other policy concerns. So just, James, from a quick logistics point of view, so we have about an hour or so total, or how should we manage time?
About an hour.
Okay, perfect. All right, so yeah, let's keep this interactive. Just feel free to jump in anytime with questions. I'll try and kind of switch between slide demo and other stuff. So it's not just kind of PowerPoint, but we'll look at things hands-on, at least in my local cluster, and see how policies can work. Quick introduction to myself, my background. I'm a co-founder and the CEO at Nirmata. We provide a policy as code, multi-cluster solution based on Kyverno. We also have DevSecOps tooling and platforms. And the idea is to provide a common set of operations and management tools for Kubernetes clusters, whether they're on-prem, cloud-based, as well as edge-based. In the community, besides being a Kyverno maintainer, I also participate in the policy working group and in the multi-tenancy working group, and occasionally with some of the other security topics, both in tag security as well as SIG security. All right, so let's, what we'll cover today is just starting with why should we care about policy management, right? Because Kubernetes itself obviously has a fairly well-defined resource model. If you look in the API model, there's actually a section called policies, right? And they talk about some resources which act as policies. So what else is required, right? And then why does Kyverno matter? How does it work? What's the architecture look like? And then we'll go through policy examples and use cases. So starting with, why policies, the way I like to think of policies are really, they're a contract, right? They are an agreement between different stakeholders. And if you kind of think about it, Kubernetes, one of the things that leads us to, believe that it's fairly complex, it's fairly involved, is there's different stakeholders who have to operate and manage various components, whether it's workloads, cluster components, shared services, things like that. So policies can help act as a contract between developers who are trying to manage their workloads, the security team, who wants to make sure that their company doesn't make the headlines for the wrong reasons, and the operations team, which wants to provide good tooling, good services to their developers, right? So all three of these stakeholders are, of course, managing operating clusters and different components. So policies can help become this, contract and the means of, I guess, digital or codified communication, if you will, across these, right? So use cases that we commonly see are obviously, as we know, Kubernetes is not, secure by default, right? It's a toolbox. It comes with a lot of power and flexibility to address a number of different use cases. But what that means is, we have to build in a layer of security before we open it up for enterprise or organizational consumption. The other thing which is very common is there's misconfigurations, best practices which are not followed. These type of things, policies can help us eliminate. And also, going back to the separation of concerns, developers, if they want to run their workloads, maybe they're fine with, of course, configuring pods and deployments and things like that. But they may not, be the right folks to configure all the other defaults, the other settings which are required to, again, securely deploy, operate, manage these workloads. So those sort of things can be, again, automated through policies. Policies is not just about enforcement and validation, but it's also about automating security as much as possible, which is, some of the use cases we'll look at. And then finally, it's, getting to best practices and a common set of shared knowledge, which you can promote organizational wide to meet whatever your requirements are for governance, for security, for, again, the goals you have for your Kubernetes clusters and deployment. So thinking about why Kyverno, and I think most folks would be familiar with. There's other policy engines, OPA being one of the popular ones, which is an acronym for Open Policy Agent. It can be used in Kubernetes along with Gatekeeper. So I'll briefly talk about the motivations for why we created Kyverno and what it does differently, and where it makes sense to use Kyverno versus some of the other alternatives. So first off, when we talk about Kyverno, we always emphasize it's Kubernetes native, right? And in some ways, that's maybe perhaps a marketing, seems like a marketing term, but when we talk about Kubernetes native, it's important to kind of go a little bit deeper and see what does it really mean to be Kubernetes native, and does it even matter in this context? Because I would argue in some products or some cases, maybe being Kubernetes native is, why does the end user care? Kubernetes is, of course, a runtime. It's somewhere you're running things. Does it matter? Before we dive into that, just want to also mention, and like it says here, we often get asked, what does Kyverno mean? Why did you call it Kyverno? So Kyverno is a Greek word for govern, and obviously Kubernetes is a Greek word for helmsman. So we kind of felt it fits nicely with the theme. So it's governance for Kubernetes, which is how the name came about, right? All right, so going back to being Kubernetes native and what does that mean? The way I kind of think about it is there's at least 5 different levels, maybe more. And this is, in discussions with folks in the community, this my thought process has evolved. So would love to hear feedback and, kind of comments on this and to say, does this make sense or not? But a lot of times when you come across products which advertise themselves as being Kubernetes native, what they mean is the product works with Kubernetes, right? So, which is great, and it's focused on Kubernetes. So maybe they call it Kubernetes native. But if you kind of go a little bit beyond that, you also want to make sure that that solution, that tool, can leverage Kubernetes APIs, can talk the language of Kubernetes through the resource model and the API structure that Kubernetes has. Perhaps another level up is that you can now operate this tool or this solution as a Kubernetes controller itself. In some cases, like with Kyverno, you'll see it plugs right into the control plane of Kubernetes, which makes it a fairly critical as well as sensitive component in your overall deployment. And that's true even with other policy engines like Gatekeeper and others, right? Finally, here, and this is where Kyverno starts distinguishing itself, because it's focused on Kubernetes. Policies written in Kyverno's, a way of defining policies, which is just declarative YAMLs, they can leverage all of the Kubernetes goodness, or, I guess, depending on your perspective, whether it's ugliness or complexity, but everything that we know and love about Kubernetes also applies to Kyverno policies, right? So things like patterns, like owner references or pod controllers, other things like, labeling, and Kyverno natively supports that because, again, it's designed solely to work with Kubernetes resources. And then finally, one of the reasons why, I feel Kyverno sort of goes this extra step in being Kubernetes native is when you install Kyverno and run Kyverno, it actually talks to the API server and queries all the metadata for every resource installed. So any custom resource, anything you run in your cluster, Kyverno understands the OpenAPI v3 structural schema for those resources. And why that matters is when you're writing policies, Kyverno policies, as you'll see, start mimicking Kubernetes resources. So if you know what a deployment looks like, it's pretty straightforward to understand what a Kyverno policy for a deployment does and how to apply it for validation and things like that. So it just seems very natural to folks who are used to writing and managing Kubernetes resources. Kyverno policies just become like other resources, other custom resources you will manage in your cluster. The other advantage, of course, is that once you because it's focused on Kubernetes, any tooling that you have built and are using for managing Kubernetes resources, whether it's GitOps tools like Flux and Argo CD, whether it's customized kubectl, all of this just kind of works, and you don't have to think twice about stepping out into a different domain to write your policies, test your policies. It's just at that point works like any other Kubernetes resource. So that, again, this focus on Kubernetes allows, and you'll see this in some of the examples as we go through, allows Kyverno to really optimize itself and simplify writing, managing policies at scale, and even getting policy results. So results in the policy results themselves are Kubernetes resources, which you can view through kubectl, or there's other tools which we'll take a look at, which can also help showcase this. So kind of going back and summarizing some of the goals, the reason why we launched Kyverno, and of course the thought process was there's already existing tools. Is this really necessary? Is this required? What problem are we trying to solve? And the feedback and the sort of embracement, the rapid endorsement we got from the community was a resounding yes. To say there is a need for simpler tools to write, manage, and scale Kubernetes policies, right? So the whole point is for anyone who's familiar with Kubernetes to be able to again create policies, apply those, to be able to also, one of the things like what I mentioned also earlier is in our view, policies were not just for enforcement or auditing, but also to automate this handoff, these contracts between your dev and your ops and your security roles, right? So having first-class support for being able to generate resources and mutate resources was extremely important, and Kyverno has really good support for that, and we'll take a look at those examples as well. And then being able to support, just seamlessly support without any additional libraries or layers of abstraction, any custom resource. So one cool thing is Kubernetes is now beyond managing applications and workloads. Kubernetes is becoming almost a universal control plane of everything, right? So if you look at projects like Crossplane, you're using Kubernetes to create cloud services. You're using Kubernetes to provision AWS or GKE or whatever cloud provider you're interested in. If you look at even AWS has, released there's something called AWS Kubernetes controllers, which also are custom resources to provision and manage things like S3 and other AWS services. So the cool thing is you can now use Kubernetes as a kernel to provision these external services. Similarly, Cluster API or CAPI uses Kubernetes to provision clusters, right? So it's not just about provisioning and managing workloads. And the power of Kyverno is now, today, it's mostly used for pod security, workload security, these use cases. But with some of these other projects, you can use now Kyverno to manage who can create clusters, how clusters can be created, how AWS S3 buckets can be created, other things like that, which really expands the scope of the governance and compliance and other things you can do with a solution like this. So that's where, and again, if you embrace the Kubernetes way of doing things, it really scales up nicely in terms of the environments and the best practices there as well. So some use cases, and
Hey, Jim, do you mind answering a question from the chat? I think we can double team this one, but if Venkat has a question, what's the difference between a network policy and Kyverno?
Right. Yeah, so policies, like I mentioned, again, is a general term, of course. Kubernetes within its API has things like network policies, even there were pod security policies, which James, like you mentioned, are deprecated. So those are built-in constructs which manage certain configurations or allow or deny certain behaviors, right? A network policy is typically used for isolating network traffic. So you would configure it at a namespace or at a workload level. and it controls the ingress and egress traffic for your pods. Kyverno is more of a general purpose policy engine. So it will allow you to do things like make sure that every pod has a resource quota, right? Or make sure that every service, or maybe you limit the number of load balancer services in your namespace. Things like that, which you would typically not do with Kubernetes objects, you can now set these constraints, these type of definitions for your cluster, and enforce these policies using Kyverno. James, anything more you would like to add to that, or?
No, I think that was a perfect example, perfect answer. So thanks for that. Venkat, do you have anything else? No? Okay. Thanks, Jim.
Sure. Yeah, so some use cases, pod security is, of course, extremely important. And I'll show a quick demo of what you can do with Kyverno and pod security. Other best practice configurations, right? So again, making it easier for developers to be able to focus on their applications, and automatically configuring namespaces or automatically configuring service resources, even use cases like if a developer creates a service, maybe you want to create a cluster-wide resource for like a Istio service, or even we've seen use cases for Calico services and things like that, right? So you can automate these type of things using Kyverno. Applying more fine-grained RBAC, right? So an example of this, a great example is, binding. So kind of there's a principle in security called trust on first use, or TOFU, which kind of binds. So when you first use something or claim something, now you're the trusted user who can reuse that, but others are not allowed to use that resource, right? So you could do that now with service accounts, because one of the challenges in Kubernetes security is if any pod runs within a namespace, it has access to all of your secrets, your service accounts, anything in that namespace by default. So if you want to restrict which pods can get to with service accounts, you can have a policy which does that binding on the first use. And then after that, only the Nginx pod, for example, will be able to get the Nginx service account and the secret associated. So if some other pod tries to mount that, the policy engine would block and reject it. So that's like more finer grain than what the standard API RBAC will allow, right? Namespace-based multi-tenancy is a very popular use case. So here, what you want to do from an operations point of view is when a user creates a namespace, you want to make sure that all the defaults, like a default network policy, which Venkat asked about, gets created, and that automatically denies traffic from any ingress or egress traffic. And then in your application, you can configure additional network policies which allow you to open up certain routes, for again inbound or outbound traffic. So that is one example. Things like resource quotas. Also, if you want to kind of have limit ranges for your namespace, which is a best practice. Other things you might want to, like roles and role bindings, you configure in your namespace. All of that can be automated through Kyverno. So this way, whenever a namespace is created by a developer or anybody with that permission, they get a secured namespace with all of the right constructs in place. Basic hygiene like auto labeling resources, knowing who created what. Kyverno can very easily automate that. Injecting sidecars, with volume mounts, things like that, which becomes a common use case. Instead of having separate controllers and admission controllers for this, Kyverno can do that. Also, kind of extending this type of pattern to say when something happens in your cluster, like if a resource gets created, whether it's a service, a namespace, some other resource, then you want to take some actions and maybe generate configs or mutate other configs. You can do that with Kyverno. And another use case, and based on time, we can even try a quick demo on this, is image signature and verification, right? So today, of course, there's a lot of buzz and headlines on supply chain security. So being able to verify that the container images you're running are actually signed by someone you trust, whether it's a build service or whether it's a human with an OIDC identity, and being able to verify that before that container is run in your cluster becomes extremely important, right? So this is worthy of its own separate talk at some point, but there's a lot of things going on in the whole supply chain security space, and admission controllers play an important role, and policy engines like Kyverno solve some of these use cases. All right, so let's kind of dive in now a little bit into how Kyverno works, what it looks like. We spoke about why policies are important, why we built Kyverno versus some of the other alternatives, and we'll look at examples of policies in action. But before we go there, it's important to understand how Kyverno works, right, and where does it plug in itself. So this is a picture from our docs, right, and in fact, I'll actually jump out of the slides over here, and we'll just go to the Kyverno docs and look around over there. So if you go
Jim,
and try, yeah,
while you're doing that, there's a little bit of chat in the chat box, but there is a question that came up from Chandra. It says, what happens if I implement Kyverno in an already existing OpenShift cluster? Is there a way to get a report on which projects and namespaces violate the policies?
Great question, right? Because one of the challenges with things like PSPs was if you introduced it in an existing production cluster, you could impact existing workloads, right? So the way we designed Kyverno, and this was one of the requirements from the beginning, was to make it easy to bring in, to apply policies without disrupting existing workloads. So you can run, Kyverno policies can be run in an audit mode. And, in that audit mode, what you can do is it will create a report, which will tell you where the violations are. And you can fix those, of course, and redeploy or update your workloads to comply then with your policies. You can also run Kyverno policies in enforce mode. And even then, what Kyverno does is if there's a, existing violation. So let's say you have a workload running, and let's say for whatever reason it's running as root user, right? Which is a bad thing. Shouldn't have been deployed that way, but let's say that's where it is. So Kyverno will report that, and if you make some changes to that deployment or to the pod, if there's no new violations, Kyverno will still allow those changes. But if there's a new violation, which based on an existing policy which you want to enforce, it will block that change. So the whole idea is that for existing violations, unless you're going to go and explicitly say you want to enforce that and update the workload, Kyverno is not going to block your existing workloads, and it's been designed to so it's easy to introduce it in an existing cluster, collect the data, and show the data. One other thing to point out is Kyverno also has a command line, which is pretty flexible and extremely powerful, right? So one of the things you can do with the command line is you can run tests, on policies. So if you're writing policies, it's pretty handy. It allows you to do tests on a GitHub repo, allows you to do tests on existing repository of YAML. But you can also run tests on a live cluster. So a cool thing is to then say you want to introduce a policy. You take your policy, you just point it to your cluster, Kyverno to that cluster, and the command line will automatically scan all the workloads, show you all the violations, so you know that even before you introduce that to your cluster, right? So that is always an easy way to find out what would happen. But again, even if you do install Kyverno, it's been designed to be pretty safe, and it won't impact your existing workload. All right, so
awesome. Thanks for that, Jim.
Sure. yeah, let's dive in a little bit into the architecture, right? So this is the picture actually I had in the slide. So if you go to the docs, go through the intro, kind of section, you will see how Kyverno works. So Kyverno is installed as an admission controller. And what that means is if you look at the lifecycle of any API request in Kubernetes, it goes through about three major phases. So there's a authentication and authorization phase. There's a mutating phase and a validating phase before that request can hit etcd, which is the typical backend, configuration store for your configuration data. So the admission control phase is that mutating schema validation, and then there's a validating phase. And the way Kubernetes is designed is it's extensible. So you can plug in admission controllers. And in fact, with every release of Kubernetes, there's several built-in admission controllers that run and do various things, like the replacement to PSPs is going to run as a built-in admission controller. So initially, you have to enable it using an alpha flag, and later on, you can then enable, as these graduate, they will become on by default. But there's built-in admission controllers, and you can plug in your own. So Kyverno operates as an admission controller, which means it has the capability of receiving any API request from any API request made to Kubernetes, whether it's from an internal controller, from a Kubernetes controller, from a user, from a machine, from an external management system, doesn't matter. As long as that API request is issued, Kyverno policies can now operate on those. So once it gets these requests, all of these policies, what happens is Kyverno goes through like a match and exclude phase to determine which policies should apply to that request. And these are, of course, policies are things that you would configure. And Kyverno builds up a cache of this in memory to be able to quickly apply this. Because you have a limit, the API server allows 30 seconds. The recommended best practice is to keep every admission request under 10 seconds. So Kyverno tries to, kind of beat that. And most of the requests are handled in milliseconds, but some requests may, require more time, especially if you're making other API server calls, etc. Right? So anyway, so as all these requests are being made, Kyverno will look up the policy cache, will apply policies for validation, mutation, and it will also record what's going on. So that recording that information is important because that allows Kyverno to generate resources later. So one other way, some other policy engines will try to generate resources using events. But events don't contain user information, which is only available during admission reviews. So that's why Kyverno uses admission review data and then will check for the resource creation to be able to generate things like we were talking about namespace defaults, etc. Right? So I see McAfee is trying to sell me something. So that's how the Kyverno engine works. And you can run multiple replicas of Kyverno within your cluster for scale. So it operates in an HA mode. In fact, when you install Kyverno, somewhere over here, I think there's a picture, or maybe it was, maybe it's in the installation section. Kyverno itself will install as a deployment. It will automatically generate a number of different configurations, like a validating webhook config, a mutating webhook config, all of the CRDs you require. And then it also uses a config map for some advanced configuration that you could do at runtime. It has secrets and service accounts that it uses, and of course your roles and things like that it will create to be able to operate in the cluster, right? So this looks complex, but it's extremely simple again to install either through Helm. You can basically this is the command to run it through Helm. If you're running it through if you want to do it through YAMLs, there's a one-liner you can use to install Kyverno with YAMLs too. And that's really all that's required to be able to run this in your cluster. So that's at a very high level, the architecture and what Kyverno looks like. So let's actually go ahead and install this and see what it takes to get Kyverno running, right? So I'm going to go to my shell. I'll switch to, so I use a Windows laptop. So this is WSL. I'm just using a Linux shell here in there. So if I look at my namespaces, I already have Kyverno running. So let's actually delete this version of Kyverno. And we'll go ahead and, so I think this was my local development copy and something I was working on. So I'm going to just go ahead and delete it from here. We'll say, and I'm just going to use the YAMLs for this to delete it. And then I'll show you how we can install it with the command we saw in the docs, right? So this is just going to clean up Kyverno and any policies and anything else I have on my Minikube cluster. So if I do get namespace, very soon, the Kyverno namespace is already gone, right? So let's go back, and in the docs, we'll grab the YAML we saw, which we'll use to install Kyverno, and see what happens, right? So this should pull down, the latest version of Kyverno from, and of course you can, instead of main, you can go to a release branch. But in a few seconds now, if I go back and check my namespaces, I see that I have Kyverno running. If I do, -n, let's say Kyverno, and so this would be in the Kyverno namespace by default. And what I want to do is just to get pods here to see what's running. So we have one pod which started. And if we kind of see the logs, we should see Kyverno came up and kind of says, configured all of the webhook, it registered with the API server, and it's ready, right? So pretty straightforward, fairly simple to kind of get going and install in a cluster. So at this point, if I do, since I installed from the command line, and even if you install from the Helm chart, policies don't get installed by default, right? So if I do kubectl get cpol, which is short for cluster policies, and see what so there's no cluster policies defined. So Kyverno is just installed, but it's not enforcing or managing any policies, right? So let's look at the first use case, which is pod security. And what I'm going to do is I saw a cool demo. Tabitha Sable did this in one of her talks at KubeCon, where she used this one-line command. I think she said it was Duffy Cooley, who is currently at Isovalent. He kind of, had tweeted this a while ago. So basically, this is showing how in Kubernetes, you can, if you give somebody access to run pods without, proper pod security, you're giving them access to get to root on host just by being able to run a pod. So what this command does, if you kind of look at it and eyeball it, it seems like a lot, but really it's running a simple, a pod, and then it's immediately, and it's running that pod with privilege is set to true. And then it's doing an NS enter into it, right? So let's see what happens. Oh, it already has root, so I guess I was trying that before. Let's remove that. And we'll try that command again, right? So what it should do, if it works, is this should put us onto our Minikube host, which Minikube, as you know, runs in its own VM. But it's going to give me root access and put me right into the host. So it opened up a bash shell. And if I see where I am, I'm actually in my slash. So if I go to proc, and let's see what's in here. So I can see everything here. If I see who am I, I'm root at this point in my host, right? So really just by having permission to run a pod without, in a default cluster, this is sort of what can be done by somebody who knows how to take advantage of privileged pods and being able to exit out, and by mounting host file systems and being able to access resources, right? So how do we prevent this? And what can Kyverno do, which is what we want to get to, right? So I'm going to delete this pod. We'll clear this up. And let's go back to the Kyverno webpage and see what we can do. So one of the cool sections in Kyverno, and this is all driven by the community, is this policies library. And there's about 84 and growing number of policies. and I'll show some of the newer ones we added. But for this demo, what we want to do is we want to go to the pod security section. And like James was saying, pod security policies, which are built in Kubernetes construct, have been marked for deprecation, and they will be removed by version 1.25. But there's a replacement being worked on by the community, which gives some default security. And there's, of course, admission controllers and policy engines like Kyverno and OPA Gatekeeper, which can do a lot more, right? So in this case, what I'm going to do is I'm going to apply a set of Kubernetes policies using this command and our Kyverno policies, and which fully implement the pod security standards. And pod security standards is a definition of controls that you want to restrict based on various levels you run. So pod security admission, which is a new feature coming in Kubernetes, it's in alpha state. It should be going to beta in 1.23. It also implements these pod security standards. Kyverno has an implementation for this, as will other policy engines, right? But let's go ahead and to complete this demo, what I'm going to do is I'm going to run this my pod security standards. So it took now if I look at my cluster policies. So if I say get cpol, I should see I have a bunch of policies. They're not all ready yet. So what happens is when policies get run in Kyverno, Kyverno automatically detects a new policy is there, and it will reconfigure the webhook to make sure that the resources the policy is managing Kyverno can receive requests for that, right? So sometimes they take a few seconds, like especially on my cluster, and when I'm on a Zoom call, things like that, it'll take a few seconds to go to ready. But now you see all the policies are ready and they're being enforced, right? So let's go ahead and try, that kubectl command again. So I think this is the command which previously we were able to get to root. And immediately what you'll see is Kyverno kind of, says, no, that's not a good idea. You're not going to be able to run that command because you can't share host namespaces. You can't, you can't run a privilege container. You cannot run as non-root. And it's also kind of requiring some defaults for seccomp, right? So by the way, I saw a question, which I think someone already answered about things like, seccomp and AppArmor. So that's absolutely correct. Kyverno does not replace those. Those would be used, still used at a host level. You would want to, enable those, use them correctly. But Kyverno can help, make sure, like in this case, that the right profiles are used and somebody's not overriding them when they're running a privileged pod. So anyway, so quick demo. This is a simple demo, but pretty. I like this one-line command, which shows an easy way to exploit and break out from a container. But then at the same time, it's fairly easy with tools like Kyverno to prevent this from happening inadvertently or for any other reasons within your clusters itself, right? So very simple kind of a quick demo to show what policies can do. And just as part of this, we also installed Kyverno and we were running it itself, right? So let me
I think
go ahead.
I just to continue on that question path, this is one more of those preventative things, but if something does get slipped through from a Kyverno perspective, you still want to have that host protection layer. So this is a defense in depth kind of thing. So
absolutely. Yeah, there's a great paper, which talks about the 4 C's of cloud security or something like that, right? Or cloud native security, and it talks about clusters or actually cloud or infrastructure as being the first layer, then clusters as being the next layer, containers as being the one layer above, and then your code as being the final layer. And it kind of goes into some detail about how all 4 layers need that protection. So Kyverno here is purely at the clusters layer. So it's definitely, you need to make sure all the other layers are properly secured as well.
Yep, I just posted that as a code container and cluster in that cloud. So
right.
if you're interested in reading more, it's in the Slack or in the Zoom chat.
Yep. So any other questions, before we kind of move on and look at some other use cases in Kyverno?
I think I wanted to make sure that as clarification, just so that my understanding was correct, because again, to continue the differentiation between a Kyverno policy and a network policy, it looks like, just reading from the documentation and Googling, that Kyverno can enforce the requirement to have a network policy as long as your CNI supports it.
Yes. So for example, if you want to make sure that every namespace has a network policy, Kyverno can do that. I'll show an example of that, how it's a fairly simple generate rule which can do that. And or you can even have other kinds of checks that if you want to be more restrictive in terms of what's allowed in network policies itself, right? So that is all possible through Kyverno. Okay, so yeah, let's kind of continue on, and I want to, in this next section, show more examples of Kyverno policies and how you can write Kyverno policies or even customize them, starting with a sample, right? So every policy has a match and exclude section, and then it has a type of rule. So the rules can be mutating rules, image verification, validation rules, or rules to generate other other type of resources, right? So and again, you can kind of have policies composed of several different rules based on however you wish to manage them. But that's the basic structure of a Kyverno policy itself. So just to kind of show an extremely simple example, like if you want to require a standard label, which is app Kubernetes IO name, which is a best practice for every workload. Helm uses the same label. Other controllers use the same label. So you can now easily, with this few lines of YAML, validate or enforce that if you turn on the validation failure action for all of your workloads, right? So pretty simple example to get started with. But then things can get more complex, and you'll see as we go into more examples. But so here, this is like with every, of course, release of Kubernetes, there might be some deprecation, some things marked for deprecation. So this is an example, and the community also, we maintain a set of policies to start warning about things which need to be removed and replaced. So you can run this policy, and it will immediately tell you about which API resources you might have which need to be updated before Kubernetes kind of just completely starts blocking them, right? So another example of a validate policy. As you can see in this, and if you look at the message block, Kyverno is able to leverage data from your API admission request, and it can then pull in that information within your policy body. So it makes it, again, pretty easy to write these policies. And all this is doing is saying, if I see any of these kind of resources, I'm going to just deny. And if I put this, by default, this will be in audit mode. But if I change it to enforce, it'll block it. If I put it in audit, it will generate an alert or a policy violation report for it. Another example, which is this is of a mutate policy, right? So now if you want to do things like, simple if then else, etc., Kyverno makes that, again, fairly easy, where you are able to, kind of write these policies, which in the first example, all it's doing is basically saying if a port is a particular number, or if it has a name, then I want to enforce that it matches a number or a range of numbers or things like that, right? Or you could say if it's not defined, then go ahead and enter that in, right? So these type of conditionals are very simple to do and add within your YAML itself without, again, having to kind of fall back into a programming language or anything like that. Example of, actually, this was what we were just talking about, or a network policy. So generate rule looks something like this. If I want to generate a default, kind of network policy, actually, this example, looking at it, yeah, it just says as policy type, spot selector. No, actually, it's not the complete policy, but it's the generate block from a Kyverno policy, which will create a network policy to deny all traffic by default for a namespace, and then you can open that up based on your workload requirements to other traffic or ingress or egress, like we were discussing. There's also a feature to keep things in sync. So one common use case of these generate policies is if you want to install secrets in every one of your namespace by default for your image registries and things like that, you can do that. And then if you change the secret, the upstream secret, the common one, Kyverno will automatically propagate that change to all of the other generated secrets within your cluster itself, right? So pretty simple way of managing things like that. This is one of the newer examples, right, of an image verify rule, which we introduced in Kyverno 1.4 and 1.5. So what this is doing is it's saying that if my image is coming from, in this case, GitHub container registry with Kyverno test verify image, and it could be any tag, then make sure that it's signed by this particular public key. So what this lets you do is you can sign the image in your CI/CD pipeline, and then you can verify it on deployment to make sure that this is an expected image signed by one of the keys that your organization owns, and you're kind of blocking other images from running which have not been signed in your by your keys. There's also a new feature in 1.5, which is, I don't have a sample here, but we can look at online, is if you want to attach attestations into your images itself, which will allow you to kind of verify other things. So I'll go back to the Kyverno docs. I'll show an example of, if I go into writing policies, and let's look for image verify, which is over here. So other than verifying signatures, you can also verify things like who has reviewed this code. Is you would create these attestations at build time, and there's actually formats there's a Linux Foundation project called Intoto, which is creating these attestation formats. And there's other projects called, so another one called Sigstore, which has various tools which help with this signing and reviewing. But this is a simple attestation, which is saying, okay, I'm making sure that any image coming from this Git repo has been reviewed by either Anna or Bob in this case, because they're the ones who are, kind of authors here, right? So these policies you can now automatically generate. You can push into your clusters and verify this kind of metadata as well for supply chain security. So some interesting kind of emerging use cases on that. So yeah, those are examples of what you can do with Kyverno. There's other features I'll talk about, but I see there's a couple of questions which we can quickly answer.
I think one of the ones, and we obviously don't have to answer it here, is it Kyverno or OPA?
Right.
I think there's going to be lots of discussions around that.
Of course.
But
yeah, so I would certainly, if you just Google Kyverno versus OPA, there's quite a few, spirited blog posts and videos and other things. My opinion, of course, is a bit biased, and I kind of mentioned some of the reasons why we created Kyverno, just to make it simpler for, in terms of approaching Kubernetes policies, have something native to Kubernetes. But yeah, there's a pretty good video which goes into quite a lot of detail. It's about from 6 to 8 months ago now, so it's already a bit dated given the pace at which the communities move. But it's a fairly good, goes through the basics. I think this was by Victor at Upbound. He put out that video. There's another really good blog post by an architect at Dell who compares Kyverno and OPA and some of the pros and cons and trade-offs you would want to consider.
Thanks on that, Jim.
Sure. Yeah, so just quickly covering more features, and then based on time, I'm happy to do more demos, and we can go into details. But one of the things I want to mention is the policy reporting is pretty important, right? And one limitation we found with other tools is that the policy reports were not always visible to the right stakeholders. So with Kyverno, policy reports are namespace. They use a custom resource which is external to Kyverno, and this resource is being some promoted by the policy working group, which can be adopted by other tools. So there's already adapters written for Falco, for Kubebench. There's another tool called KubeArmor, which is writing an adapter to this. So the idea is, independently of which tool produces the report, you have one common way of viewing these violations, seeing what has passed or failed, or what's happening in your cluster, right? So a pretty interesting feature and something to look at. And in fact, there's even discussions with Gatekeeper to see, how we can, from the policy working group, help them write an adapter or create something which pulls in results into this common format. There's also, because there's a common format in the community, Frank Jogile, who was one of the folks who was also created Falco Sidekick and some of the tooling around it. He wrote a policy reporter tool, which is a pretty nice tool to view policy reports within your cluster. It's a graphical tool, and it also has a neat feature to send notifications to other kind of systems like Slack or Discord or even Loki and Teams and other things, right? So pretty nice solution for that. Kyverno itself publishes policy metrics, right? So there's all sorts of counts and execution and status and things like that that you can get. There's a Grafana dashboard, as you would kind of envision or want. So if you're running Prometheus and Grafana locally, if you're running through other controllers like Nirmata or other external systems, they would use like OpenTelemetry agents to be able to get this data and be able to view that in upstream systems, right? So because it's important to know, like, are your policies executing correctly? Are they, are there errors? Are even your webhooks configured? So things like that, now become visible. So if your error rate spikes, it's a pretty good indication that somebody is trying, a bunch of privilege pods or things like that, which you might want to take some action against. There's also, I mentioned the CLI already, but the CLI is really handy in writing, test kind of commands, making sure things can proceed. And I can quickly show even what that, in fact, I have that perhaps in my other console. I'll show what that looks like if so if I run this CLI test, this is just running against my local directory, gives you a nice kind of report for all your policies. You can have like success and failure use cases and see, and this is running a bunch of tests in my local development directory, right? Because that's why it's going through, just to audit and make sure that whatever changes I made didn't break any of our existing policies and things like that. But you can do this, of course, for your YAMLs, and this is all offline, right? You don't need a cluster. Although the CLI, if you look at the examples, you can run it against a cluster. One of the things it will do, so if we do apply, which is the command to apply a policy, and look at the help page for that, it allows this cluster option where you can point it to your cluster, and it will apply any set of policies, either in a folder or in a Git repo, into either resources locally or resources on your cluster. So pretty powerful in kind of testing, debugging, and validating things. So certainly those features are also important to kind of, as you're running policy engines, because as I mentioned, they become critical components. So looking at the metrics, looking at testing, how you manage policies at scale, things like that. All right. I see there's a couple of other questions. So I think one question was, any tooling to transform OPA Rego into Kyverno? It's a good idea, but no, not yet. So today, I think in a lot of cases, people just end up starting with the samples library and kind of customizing policies there. And if tools from Replicated can work with Kyverno, I'm not familiar with. Bill, is there any specific tool from Replicated you had in mind, or? Yeah, I'll have to look at that. I'm not too familiar with that. I don't know if anybody else is, but Kyverno, yeah, can certainly be used outside of a cluster, like through the CLI. And if you're running it within a cluster, it will kind of do the reporting. Yeah. So if you have other config scanners or other tools, they would not interfere with Kyverno or vice versa. But yeah, to use them together, I'd have to think about what the use cases there might be. Okay. Yeah, thanks for the link. I'll certainly take a look and see, and kind of what if there's other integration possibilities, things like that. So just to kind of quickly summarize, and sorry, go ahead.
I pulled up the link, and I'm gonna have to look into it because it looks interesting. Anyway, okay. Sorry, go ahead, Jim.
No worries. Yeah, so just to quickly summarize, I know we're a little bit past the hour, and happy to kind of hang out longer, and we can look at some more demos. But really, the whole goal of Kyverno is to make policies very native and customizable to Kubernetes to help with security, automation, best practices, like we saw some simple examples, and make it easy for anybody who understands Kubernetes, because Kubernetes itself has a pretty large learning curve. So, not creating an additional set of things to learn on top of Kubernetes to get started with Kyverno, right? And certainly the community is very active. We have about almost like 80 or so contributors, growing number of maintainers, and always kind of looking for more use cases and things we can help solve. So feel free to browse the docs, join our Slack channel, just try out the sample policies. If you're not running pod security or any form of pod security today, pick either OPA, Gatekeeper, Kyverno, whatever you wish. Try both, but it's definitely worth running one of these. And as pod security admission becomes, I guess matures and goes into beta or GA, you definitely want to look at what the built-in option does and how Kyverno or other policy engines can further complement and extend those built-in options, right? There's also, by the way, Nirmata, my company, launched a training and certification, which is free. So you can just go to learn.nirmata.com, and kind of go through Kyverno over there. There's a quiz also to get a badge, things like that. So definitely try it out and give feedback there. But that's pretty much all I had in terms of the main presentation. And again, happy to show demos on any of the policy types we talked about, or answer any other questions that folks may have.
It's a great presentation on Kyverno. I know I've got a lot to investigate. I have not. I actually just opened up an issue on GitHub for Ingress about we need to update our documentation off of pod security policies. So this was definitely like a really good timing for us. So thank you for that.
Yeah, by the way, there was one quick thing I'll show, and we just put this out also in our policy sample library. If you are maybe aware already, there was a CV on Nginx, custom snippets, right, which was published and put out.
I know very, very well.
Right. Yeah. So, and this is a Kyverno policy which will let you block that configuration. So if you don't want to allow any config maps to have this configuration, as well as to make sure that if you're running ingress, that annotation is not allowed. So this is also, again, if you're running Nginx ingress, definitely good to try out this policy and just check and see. There was also other kind of CVEs in the past that were put out on services, which allowed I think there was one which allowed you to configure external IPs. We have a policy for that. So several examples of pretty useful policies you can quickly write and deploy on your clusters. Any other questions, thoughts?
Gotten lots of questions in the chat, so thank you everyone for that. It's always helpful when it's a little bit more interactive, so I appreciate everyone asking questions in the chat. Well, if we've got no more questions from the audience, Jim, I wanted to thank you for coming to Cube Philly and explaining Kyverno for us. So with that, everyone, like I was saying, thank you. We've got November and December coming up. November is looking really interesting from a distro list perspective. We've got a dev advocate from JFrog coming to talk to us. So looking forward to that one and seeing everyone next month. If you have any questions or comments, you guys know how to reach out to me, StrongJZ on most platforms. So thanks again for coming, and thanks again, Jim.
Thank you. Take care, everyone. Bye-bye.